Hello and welcome back. And from this particular video, we are going to start a new project in the machine learning. And this machine learning project is all about the digit recognition, the handwritten digit recognition. You must have seen, the places where you have some handwritten digits, and we want to automate this. That no one need to be there. A human don't need to be there to recognize that digit, but there should be a machine learning model which is able to identify that particular image which is containing a particular digit. Okay. So for that, we are going to create this particular machine learning model. So in this machine learning model, I have written the piece of code here. So I will explain this piece of code and we will run this as well, just like in the previous project we have done. So the same thing we are going to do with this project. And we will discuss the mathematical concepts along with the functions that have been used in this particular program. And these are very simple programs. This is whatever I'm training you, whatever I'm telling you, all these things are very much helpful to those who are in the beginning stage, who are the beginners in the machine learning area. Okay. So first of all, let us see what all I have used here. So you must need to have this TensorFlow. This TensorFlow library you must need to have installed. So how you will install it? You need to simply run this command pip install TensorFlow. Okay. So once you run this, then you will be able to see like the TensorFlow library is getting installed. So I have already installed it. So it will show me that yes, all the requirements have already been satisfied. But yeah, if this has not been installed, then it will, install all the dependencies one by one. Okay. So this is the one library that is needed here. And the other library which will be needed for testing your images that you will provide to your application, those things we are going to discuss in the coming videos. Okay, so that library is OpenCV library. So that library also you need to install. So what I have done in this project that I have simply created two files, two Python files. One file will be to train your model and save the model, persist your model. And the second file will be to read from that model, that trained model, and apply that trained model on your image of digit that you have provided, your handwritten digit that you have provided to get the output. So this is the way we are going to learn it, right? So first, this is the one, this program you can see like I have simply uh, simply save the model at a particular location on my hard disk. And after that, then there is another program which is again a Python program, and I'm opening that model which I have saved here in this one, and then I have opened it. And after opening it, I have asked the user to provide the image, which is the handwritten digit image, and then I have used the OpenCV library to just readjust the image with the trained model image, because our trained model images will be trained on the 28 cross 28 pixels, right? So we need to have the same resizing of all those images that you are providing to find out what is the digit actually, right? So here you can see like we have seen these things here, like resizing I'm doing, and whatever image you have provided with along with the path. This is the client program where you will provide the image with the path. Don't worry if you are not able to understand few things. Doesn't matter at all, because I'm going to discuss these things one by one in the coming videos. This is just for the introduction. So this is a client program where you will provide the image, and you will load the train model, and with the help of that train model, you will pass the image that you have taken from the hard disk as an input from the user. Then after that, what you will do, you will predict the image using the same model that you have trained. Okay. So this is the overall objective. Very simple program, but the mathematics and the machine learning involved, all the concepts involved, all the functions involved, they are the most important things that you must need to understand. So first of all, let me tell you in this video that you need this TensorFlow. And the second thing, you need to you need to import these things like MNIST, sequential, dense, dropout, convolutional 2D, and max pooling 2D, flatten. And then for optimizer, I have taken this one, although this is not needed. But yeah, I have added this, and in fact, this is not needed. So let not add this to avoid the confusions. So So you need the TensorFlow and you need the pickle. Pickle you need to save your model, and TensorFlow you need to have all those functions which are used in the convolutional neural network, because based on the convolutional neural network model architecture, we have trained our model to identify the images. What is the convolutional neural network model? All these things we are going to discuss one by one. So although the program is very simple, but my target is to learn the machine learning, right? Understand the machine learning behind these programs, behind these models, so that you can understand with the help of the simple examples that how the machine learning models work, what all you need to know, what all are those libraries. So with the help of small projects, we will be able to understand these things. And don't worry about the code. I will be providing you the code. Okay, I will give you the code. So you can see the description section. So you can download it from there, or you can copy paste it from there. Okay, so let's start with this MNIST, right? So I will just tell you about this MNIST. What is this in today's video? So what is MNIST? Let us first understand that. And you can easily understand that this MNIST is just the part of the TensorFlow. But we must need to understand that what this MNIST stands for and what is this MNIST and why it is used. Okay. So let us understand what is MNIST dataset. Basically, MNIST is a dataset. It is containing that data which is used by our machine learning program to train the model and also to test the model. You know that whenever we use some training data, then to train the machine learning model, then in that case, some of the data that has been used for the training, we get some of the data among that training data to make it a test data, right? And when we make the test data, then we just provide the features and we get the output, and we match the output with the test data output, and we match if they are matching a lot, or you can say they are matching to a certain extent, to a certain threshold, more than 95 or more than 97%, then we say that yes, our model is pretty good to use. Okay, so MNIST is basically a data set. What does it contain? First of all, what does it mean, MNIST? So MNIST stands for Mixed National Institute of Standard and Technology. It is a widely used data set for handwritten digit recognition tasks in machine learning. So this MNIST dataset is basically used for training those machine learning models, which will learn to identify the handwritten images, handwritten digits. Okay. So what does it contain? It contains 70,000 images overall, and all those images are handwritten images, and all those images of the digits are between 0 to 9. So there are 17,000 images of handwritten digits, and all those digits are between 0 to 9. So in the different ways they could have been written, so that our model can be trained to identify in the different ways. So whatever way you present any digit, it should be able to identify that yes, this was the digit. This is the digit which user is asking me to identify. Okay. So among the 70,000 images, there are 60,000 training images. So among the 70,000 images, we use 60,000 training images, and then we use 10,000 testing images. So this data set is already there. So when we train our model, then we have the reference data. Just like in the previous model, where we created the sentiment analyzer, in that case, we have to prepare the data ourselves. But here, we don't have to prepare the data ourselves. The data is already there. Okay, so we don't have to prepare the data. So these images are 28 cross 28 grayscale pixels images. So 28 pixels cross 28 pixels, which means this is kind of a matrix. So I will let you know that how the matrix plays a role in digit recognition. So basically, every image is it can be represented in the form of a matrix. How it is represented, why we do that, why we use the matrix only, that all we will discuss in the coming videos. So there are different classes. There are 10 classes. Classes means each digit will represent one class. Like digit 0 is representing class 1. Digit 1 is representing the other class. Digit 2 is representing the other class. And similarly, digit 9 is representing the class number 10. So there are 10 different classes in this data set for different digits. Okay. What are the key features? So these are the normalized pixel values between 0 to 255. So I hope you know about, the uh, color pixel values, and 255 means it's a kind of a white image, right? And something between 0 to 255 is could be a grayscale kind of image. Okay, grayscale kind of value for the color, right? For R, G, and B combinations, if we apply R, G, and B with 255 each, then that combination makes a white color. If you use the different color combinations, then you will be able to get the different combinations of the colors, right? So these images are using the normalized pixel values between 0 to 255, which means like there are different images with different color combinations which have been used for the training and the test data, right? And that test data is MNIST, right? And then comes the centered and size normalized images. These are the centered and size normalized images. Please note this down, because if you will find out some image when you will be using this model, in that case, if you provide some kind of image which is not centered, okay, then in that case it may be that it will not be able to identify the image correctly. There are balanced classes, approximately 6,000 images per class, which means there are 6,000 images per class, which means like for digit 0 there are 6,000 images, for digit 1 there are 6,000 different images, for digit 2 there are 6,000 different images. Okay, so for each class, like for digit 0, for digit 1, for digit 2, for every digit, these are considered as different classes of images, different classes of digit images. And for each class, there are 6,000 images in different flavors. Okay, somewhere 2 must be written like this, somewhere 2 must be written like this, somewhere it may be like this. So the color combination may be different, it may be a different color combination, it may be a grayscale, it may be a black and white image, right? So in the various flavors for each class there are 6,000 variants they have used for having the training data. So you can understand that how powerful this library is. But yeah, if you don't choose the model properly, if you don't choose the your activation functions, we will discuss about the activation functions. So if you don't choose those activation functions and all the things, you don't consider wisely all the concepts that are used in the machine learning for digit recognition or for the image analysis, then in that case you will not be able to train your model sufficiently to identify the correct digits. Okay, so here the features are like there are 60,000 images which are used for training, so 6,000 image per digit have been used. Okay, now, what are the uses? So, this library is used for handwritten digit recognition, image classification, neural network training and testing, benchmarking, machine learning algorithms, right? So, these are the different uses of MNIST data set. And what are the benefits? Simple and well-defined problem, large and diverse data set. You can see there are 6,000 per class. So, this is really a large and diverse data set. Widely used benchmark for comparison. It's a benchmark, MNIST, suitable for various machine learning techniques. Okay, some popular deep learning models for MNIST include convolutional neural network. You probably may be available, may be aware or may not be aware about these concepts. But yeah, as soon as we will move ahead in this playlist, we will understand these things. Okay. Now there comes autoencoders, generative adversarial networks. So all these things are there, which are which are using the MNIST data set for training the models. So what performance metrics it uses in the previous project, in the last video we have discussed about the accuracy, precision, recall, and F1 score. Why these are used? These are used by the machine learning models to identify how precisely and how accurately my model is predicting on the real values. Is it able to, will it be able to predict the values correctly or not? So all these parameters, accuracy, precision, recall, and F1 score. F1 score is the harmonic mean. So all these things basically decide whether the model is perfect or not for the for the prediction. So all these scores are utilized for that. Okay, so accuracy is more than 99.7% as per the uh, you know uh, understanding and as per the experience by the different developers used for training your machine learning models. So MNIST serves as a foundation for more complex computer vision tasks and is an excellent starting point for machine learning enthusiasts. So this is just a pointer for you to understand that why MNIST we are using and what is the significance of MNIST uh, dataset. So I hope you must have understood it to some extent, and as soon as we will move ahead in this video, in this project, you will be able to understand it more precisely. So I would like to say have a nice day to all of you, and we'll meet in the next video. Till then, have a nice day and bye bye. Thank you.